Now the third concept we're going to deal with antiderivatives is something called an initial value. Now all this is describing is we're given the first derivative equation, and that first derivative equation is going to use an initial condition to help us find the actual function without listing the constants as variables. So letter G, we're going to go ahead and simplify this one first before taking the antiderivative, just to make this a little easier. So we can take the antiderivative to get y is equal to x squared plus x to the negative third. Now if we take the derivative one more time just to check it, this is 2x. This would be minus 3x to the negative 4, so it looks good. And then from there we can say it's plus c. This would be our general antiderivative, but in this case we're looking and they're asking us in the directions to find y or f. So we need to find the actual equation for y, not just with the letter c. This is what's creating the problem right now, and that's why we're given the initial condition. So we're going to take 3, plug it in for y. We're going to take 1, plug it in for x. Solve for c. This would get us a c value of 1. And so our actual equation for the original function will be x squared plus 1 over x to the third plus 1. And that is our initial equation, the initial value equation. Remember, you can take your equation and check it. I certainly encourage you to do that. X squared, its derivative is 2x. X to the negative third, its derivative is negative 3x to the negative fourth. And then the plus 1 we can use by taking 1, plug it in for x to get 1, plus 1, plus 1, which gets us 3. Please, please, please take the time to check it. You don't have to write anything down, but it is certainly helpful to make sure you're getting it right. For letter H, we have a second derivative. So we're going to use the initial condition twice. We have an initial condition of f of x. We also have an initial condition for f prime of x. So we'll go ahead and take the first derivative, the antiderivative one time here first, but before we do that, we'll simplify this to make it a little easier. So our antiderivative will be f prime of x is equal to 6x to the 1/2 power plus c. We can quickly check this to make sure we did it right. That would get us 3x to the negative 1/2. From there, we're going to plug in 7 for f prime of x and 4 for x. So this will be 6 times the square root of 4 plus c. So this is 7 equals 12 plus c, so our c value is negative 5. So our first derivative equation is f prime of x is equal to 7 times the square root of x subtract 5. We're going to go one more time here to calculate the original function. So we'll go the antiderivative one more time. This is going to be f of x is equal to 6 times x to the 1/2. We're going to add 1 to get 3 over 2. So it's 4x to the 3 over 2 power. A quick check on that to make sure the derivative is right. 3 over 2 times 4 is 6x to the positive 1/2. That looks good. And then we also have subtract 5x and then plus d. Now we're going to take our initial condition of f of 4 equals 20. We can plug 20 in for f of x and 4 in for x. So this will be 4 times the square root of 4 to the power of 3. Subtract 5 times 4 plus d. So 20 is equal to 32. Subtract 20 plus d. And this gets us 8 equals d. So our equation should be here f of x equals 4x to the 3/2, subtract 5x plus 8. We'll do a quick check of this one as well. If we plug in 4 for x, we get the square root of 4 is 2, cubed is 8, times 4 is 32. Subtract 20 is 12, plus 8 is 20, so that looks good. Make sure our first derivative is right. 4x to the 3/2 will get us 6x to the 1/2. That looks good. Subtract 5, so far it looks pretty good. The derivative of 6x to the 1/2 gets us 3x to the negative 1/2. That looks good there. And then this would get us 0. And then if we take f prime of 4, plug 4 in, we get 2. Times 6 is 12, subtract 5 is 7. So that's a whole lot of checking, but certainly something you can do in your head to make sure you're doing it right. For letter I, when we continue for an initial value, before we take the antiderivative, we'll simplify this. So we distribute the square root of x to get 6x to the 1/2 plus 5x to the 3/2. Remember, we're taking x to the 1/2, multiplying it by x to the first to get x to the 3/2. Now it will be the antiderivative. So g of x is equal to 6x to the 3/2, and remember we're going to divide it by 3/2 or multiply it by 2/3, plus 5x to the 5/2, and we will go ahead and multiply that one by 2/5, which is dividing by 5/2. So to simplify that, it's g of x is equal to 4x to the 3/2 plus 2x to the 5/2 plus c. I forgot c already, so I'll always look to see if you can include that. It's important. It's something that's forgotten a lot. To solve for c, we'll go ahead and plug in 1 for x and 10 for g of x. So 10 is equal to 4 plus 2 plus c, which gets us a c value of 4, and our answer should be g of x is equal to 4x to the 3/2 plus 2x to the 5/2 plus 4. Before continuing, I am going to check this. So if you plug in 1, you get 4 plus 2 plus 4, which is 10, so that looks pretty good. The derivative of 4x to the 3/2 gets us 6x to the 1/2, so that looks good. 2x to the 5/2 will get us 5x to the 3/2. That also looks good. And then the derivative of 4 obviously is 0. So again, checking it is very beneficial. All right, letter J, we're going to find, again, an original function. Now here we have two conditions. And keep in mind the two conditions, there's not an f prime in either one of these. So as we solve this and we get a general equation for f of x, we're going to have a c and a d, and that should help us. That should help us, this one especially, because it's 0 equaling 8. So let's go all the way through, get the general antiderivative, and then we'll use those two values to find the actual equation. So f prime of x is equal to 5x to the 4th plus 4x to the 3rd plus 4x plus c. Check it just to make sure. 20x to the 3rd, 12x to the 2nd plus 4, and then plus 0. Our next equation is f of x is equal to x to the 5th plus x to the 4th plus 2x squared plus cx plus d. One more time, we'll check that. 5x to the 4th to get to the first derivative here. 4x cubed, that looks good. 4x, that one looks good. And cx, its derivative is c. So we'll use our two conditions that are given to us. We'll first take 0 and plug it in for x. So we get 8 is equal to 0 plus d. So already we have a d value of 8. That's important. We're going to add that back into our equation. F of x is equal to x to the 5th plus x to the 4th plus 2x squared plus cx plus 8. Now we can easily find c by plugging 1 in for x. So 5 is equal to 1 plus 2 plus c plus 8. As we simplify that one out, that will get us 12, and then c is going to get us negative 7. We'll make sure that's right here. 2, 4, 12, yep, negative 7. So our final equation will get us f of x is equal to x to the 5th plus x to the 4th plus 2x squared minus 7x plus 8. We will once again check this. 5x to the 4th, that looks good. 4x cubed, 4x, and then a minus 7 would be the value that we get in there, plus 8. Now, simplifying it here, we plug in 0. We certainly get 8 all the way through there. We plug in 1, we get 1 plus 2 is 4, minus 7 is negative 3, plus 8 is positive 5. That looks really good for our answer.